Class practice 35.2. Let's look at the equation. Given that the heat of combustion of ethanol is negative 1,371 kilojoule per mole, and then heat of formations of carbon dioxide is negative 393.5 kilojoule per mole. Formations of water, H2O liquid, negative 285.8 kilojoule per mole. Determine the standard enthalpy change of formations of ethanol. Now let me repeat. What is the definitions of the standard enthalpy change of formations of ethanol? It is the enthalpy change when 1 mole of ethanol is formed from its constituent elements. Its elements are carbon graphite, hydrogen H2 gas, and O2 gas. According to the definition, we need to keep these coefficients as 1, then 2 and 3, and lastly half O2. Now, how to solve the problem? Now, as I said before, you must highlight your target. This is the equation. This is your target equation. Okay. Please copy down horizontally in your cycle. Energy change cycle or enthalpy change cycle. Now I'm showing the energy cycle or enthalpy change cycle. Okay? Change. Oh, this is your target. You are required to work out this delta H. It is the standard enthalpy change of combustion of ethanol. Now, let's look at the given equation. Here we have the ethanol. Here is the ethanol. So obviously, connect them up by adding 3 oxygen. Finally, we have 2 carbon dioxide and 3 hydrogen. 3 water are produced. Okay, and then next we maybe I label it as delta H1, which is equal to negative 1371 kilojoule per mole, because we have 1 mole of ethanol burned, okay, completely. Now let's look at this. We have 2 carbon graphite. Okay, we act with oxygen to form carbon dioxide. Besides, we have hydrogen. We act with oxygen to form water. Now, first of all, I balance the equation first. Altogether, we need 4O, 7O, and here there is 1O already. That means I need to add 3 more. Now everything is balanced, okay, in the cycle. I label it as delta H2. Now what is delta H2? Delta H2 is equal to the summations of 2 terms. The first one, you can see that graphite changed to carbon dioxide. However, there are 2 moles in the equation, and according to the data given, 1 mole of carbon dioxide produced, the delta H is equal to negative 393.5. Now we have 2 moles, so 2 times 393.5. This is the first part. And then another part, we have hydrogen, okay? We act with oxygen, okay? And then all together we have 3 moles of water. according to the definition, when 1 mole of water is formed, delta H is equal to negative 285.8. Now we have 3 moles, so 3 times negative 258.8. Can you follow? Next, use your calculator. 2 times negative 393.5 plus 3 times negative 285.8, which is negative 1644.6 kilojoule per mole. This is delta H2. Do you understand? Can you follow? Now, let's use Hess law. Here, you must identify. We have 3 arrows. 2 of them belong to the same root. I use green pen to highlight them. This one, caught-rise. This one, caught-rise. That means both of them belong to the same root. And then next, this is another root, delta H2. Can you see that? According to Hess law, delta HC plus delta H1 should be equal to delta H2. Therefore, delta HC is equal to delta H2 minus delta H1. Therefore, it is equal to negative 1644.4 minus negative 1371. 1371, okay? Minus, that means plus 1371, which is negative 273.4 kilojoule per mole. Do you understand? Now, please pause the video. Try to finish it by yourself. Question number 2. Given that the first equation, the second one, the third one, construct an enthalpy change cycle to determine the standard enthalpy change of the following reaction. Again, the first step, please highlight your target equation. This is your target equation. In drawing the cycle, I will copy this equation horizontally. This is the delta H that we are looking for. Now, here we have Fe2O3. Fe2O3. So we act with 3 CO, okay, to form Fe and 3 CO2. So I will draw the arrow pointing it downwards. Fe and CO2. Now, for 1 Fe2O3, it needs 3. Now we have 3. That means we need 9. There is 1 already. In other words, I need to add 8 more here. Then we have 6 Fe and 9 CO2 produced. I label it as delta HA because I don't want to mix up with delta H1, delta H2, and delta H3. I use delta HA. What is delta HA? It is equal to 3 times negative 11.5, which is negative 34.5 kilojoule per mole. Next, we have this equation. Okay, now be careful. This is the product. However, this is the reactant. Okay, you may reverse the equation, or you may keep this direction. It doesn't matter. Now maybe I look at another one. FeCO2 to form FeO and CO. I think I would like to use this one to continue with my cycle. Here, Fe. Add one more arrow. Label it as delta HB. For 6 Fe, it needs 6 CO2. Is that right? So finally we have FeO and CO. For 6 Fe, it needs 6 CO2. That means we have 3 CO2 left. And then we have 6 FeO and 6 CO. So obviously delta HB is equal to 6 times negative 0.5, which is negative 3 kilojoule per mole. It is delta HB. Lastly, we have 6 FeO, 3 FeO. Okay, then two times 2. Now, it is difficult to relate all these equations in a cycle. Now, I will show the answer, but it is difficult to understand. Okay, you may try. I will show you another way. It is easier. Now, first of all, I would like to change this direction from forward to backwards, and then I will add 8 mole of carbon monoxide, because at this part I have 8 moles. Okay, and then here we have 2 FeO3. We act with 2 of them. We act with 2 of them. Okay, so that 6 FeO and 3 CO2 are produced. In other words, this is delta HC. This is delta HC. Delta HC is equal to, I need to reverse this one and then multiply by 2. 2 times plus 9, which is 18 kilojoule per mole. Reverse, need to reverse. Sorry, I have forgotten. Reverse, negative 18 kilojoule per mole. Now let's use 2 color highlight pen. This is the first root. This belongs to the first root. However, this one and this one belong to another root. Can you see that? Clockwise, clockwise, anti-clockwise, anti-clockwise. In other words, delta H plus delta HC is equal to delta A plus delta HB. So delta H is equal to delta HA plus delta HB minus delta HC. Now, finally substitute all the data into the equation. 34.4 plus -3 minus 18. So the answer is -19. Have I done something wrong? Is this one? Yes, sorry, I copied down it wrongly. -19.5 kilojoule per mole. That's the answer. Now I think it is too difficult to draw the cycle, okay? So I'd like to show you another approach, that is by elimination. Bear in mind your target. It is your target reaction. Free Fe2O3 plus CO 2 Fe3O4 plus CO2. This is your target. You want to work out its delta H by using the equation given. First one, here we have Fe2O3 on the reactant side. So I will copy down in the same direction. Besides, I need to multiply the whole equation by 3. In multiplying the whole equation by 3, bear in mind the delta H need to multiply by 3. Okay. Next. We have Fe on the product side, and here we have Fe. So I'll copy down the third equation, multiply the third equation by 6. Because I haven't changed the direction, so keep the sign. And then next I multiply the whole equation by 6, so which is -5 times 6. -0.5 times 6, which is -3. In summing these two equations up, you can cancel out Fe because Fe does not appear in our target equation. Do you understand? Now next we have introduced FeO on the product side. We need to cancel it out. So by using the second equation, because we have FeO, I copy down and then multiply the whole equation by 2. In multiplying the equation by 2, I need to multiply its delta H by 2. I haven't changed its direction, so keep it, which is 18. Do you understand? Again, in summation, you can cancel out FeO. Can you follow? Now, lastly, let's check. We have 3 Fe2O3. 9 CO, 6 CO, and 2 CO. Lastly, you have 1 CO on the reactant side. Next, we have 6 plus 2, 8 CO2, and there is 9 CO2. So there is 1 CO2 on the product side. In other words, in doing summation, you can work out the target equation. Similarly, for the delta H, simply sum them up. Negative 34.5 minus 3 plus 18. It is the answer, negative 19.5. Bear in mind, write down its unit, kilojoule per mole. Then you can work out the answer easier, okay, by using this method. To understand? Now, I think for question number 2, it is better to use this approach rather than the cycle. It is difficult to draw the cycle. It is difficult. Okay? I think you are not necessary to learn how to draw the cycle. Simply use summation. Use summation to work out the answer. Again, please pause the video and try by yourself.